It's such a great honor to be here on this wonderful occasion because I often ask myself, how did I ever get to work with people like Martin in the first place? Like just little me, it's been an amazing experience. It's been many years since we did that. Martin is probably much relieved, but I kind of miss it. It's just great and a lot of familiar faces here. So this talk, to be clear, is much more questions than answers. I don't have any answers to this question. Of course, programming has a future. We all have a future, but we know what that is. And so the question is programming on the same track as humans are. But I think that there's interesting stuff around this question that we can discuss. Since we are talking about the future, everybody knows me. There needs to be an Orwell quote in every talk. Yeah. And this is I've used this quote in talks in the past because it is one of my favorites. It's kind of interesting, right? We have the obvious link, right? Who controls the past controls the future. So there's this arrow right here, which is causality. That's kind of obvious. But what makes it interesting is the other line, who controls the present controls the past, and that's sort of an arrow of perception of how you present the past, how you think about the past, because it's a question for physics and metaphysics. Basically, the past is really in our minds, and so we're going to talk about a little bit about the past because it is a Festschrift and all that, and a bit about the future and a bit about the present. So, what happened to my cursor? There it is. The past. So, this is Phil Wadler. This is Martin. This is me. It's amazing what a difference a little bit of hair makes. And this is David Staudemeyer, who was in charge of the Java-C compiler in those days. And this all started. Martin visited us in Cupertino at the Sun offices, and he and Phil had done this work on a thing called Pizza, which was some sort of Java variant with parametric polymorphism. And we talked, and it seemed to us at Sun as the best way forward for doing this. There were many other schemes, and the people who had other schemes hated us because we didn't choose their scheme. But anyway, we chose what we thought was the best scheme given the circumstances. And I thought I had this picture, but I did not. So I said, okay, I know this picture exists. I remember it, and I should go find it. And so I said, I'll just type in, Martin Odersky, Gilad Bracha into search engine, and then I'll click images, and it'll be there. And it indeed was there. There was only one thing, I've elided a step, which is when you do this, before you get to images, it brings you other results. And what do you think the top result you get for that query is? This literally is the top line with the best part quoted here. I mean, me, okay, drunken certainly, but Martin and Phil, okay. So but it does capture some of the atmosphere and fun around that whole project of Java, because you do something that affects a lot of programmers, and and that is very constrained in how you must do it, and they love you for it. So that was fun. I thought before doing this talk, should I do some sort of retrospective and talk about all this stuff? But no, it's very boring, and I don't want to revisit it. As you can see, there were other great quotes but I'll elide them. So we'll just move on. But we'll talk about, this is really about the present. And does everybody know what's in the picture? Okay. This is called a Shoggoth. There was I guess it's sci-fi, whatever, an author called H.P. Lovecraft, and he wrote, these sort of horror / sci-fi stories, and there were lots of interesting creatures there. And one of them is the Shoggoth, and the Shoggoth is it's fun. It's a dynamically allocating monster, so it creates tentacles and eyes as needed on sort of as you go. And this has become one of the symbols for the AI doomers of AI. Essentially, as we'll see, their idea is that AI is a masked Shoggoth, so it's holding a mask with one of its tentacles to look nice to the human users while it plots the extinction of the human race and so forth. So we'll get there. So in general, right, we're sort of where these people wanted to go in, I think it's 1977 or so, whenever this paper was published, The Programmer's Apprentice. And they wanted something that'll help programmers and kind of, know enough to really give you real assistance when programming using AI. And what they had then was not really up to the task, of course, but they had the vision, and it's sort of here now. And that's isn't that great? So we're definitely in a new world. And I imagine that all of you have been exposed to this at some level, because the hype engine is at such a level that really it's in the newspapers and everything. But programming itself, or programs at least, are still necessary, because you can ask one of these things to do something, and setting aside whether it'll do it right and all these questions, it is a humongously expensive way to get anything done. I mean, it'll do things that nothing else can do. But if you can do something that you already know how to solve, then it's a great way to, spend a lot of electricity and energy and so forth. So what you really expect them, for any problem that you can, you'd like them to not to answer it, but to write a program that'll answer it. And so programs are still in business. And programming languages, well, that's a bit of a more interesting question, isn't it? Because potentially these things could just write everything in machine language and they wouldn't need programming languages. But the way they work, they seem to need help just like humans do. The less detail they have to actually work through themselves, the more likely they are not to screw it up. It's quite interesting. So the similarities to humans are sort of uncanny sometimes. So I'm sort of hoping that programming languages are still in business as well. But that is already a question. Now, there are lots of implications for programming. The thing about these, we're talking about large language models, right? LLMs. And they're sort of like the old nasty jokes about the policeman who can write and the policeman who can read. So they're really good at writing, but reading their stuff, you want a situation where ideally to use them, you want something that is difficult or tedious to write, that it'll write for you, but it's easy to read because you need to check on them because you can't trust them, right? Now, programs aren't really like that. Yes, they are hard to read, but unfortunately, they are hard to read. They are hard to write, and unfortunately, still hard to read. It is not that easy to verify that a program is correct. And so even if it writes it for you, you have to go read it, and you're almost as, you're not worse off, but you're not much better off than you were before, because people still like it. A lot of programmers' usual day job is full of boilerplate, and they generate boilerplate. And for a lot of boilerplate, it's pretty remarkable what it does, but you still basically cannot trust it. So there is one area where I think we'll see progress, or people are already doing this, is test-driven development, because tests are also, they're not hard to write, they're tedious to write. And this is really good because they're relatively easy to read and verify, because they're straight line code and you sort of knew what you expect the thing to do. And so we may see a methodology where you tell it what you want done, and you tell it to write tests for that rather than write the program. And once you have the tests, you're halfway there, and then you can maybe get it to try and write it and compare to the tests and improve it things. So that's one area where we can see, imagine that things are already happening that may be this way. More interestingly, a lot of stuff that I traditionally have not been fond of may finally work. Of course, a lot of people here think they work already, but things that are too complicated for humans, like fancy type systems and working with formal systems and proof checkers, if the thing can write them, and if what gets written is actually comprehensible. So, for example, wildcards would not be an example that helps, because wildcards have the property that they're actually harder to read than to write. You write them, you thought you knew what they were doing, later, never mind. Martin did warn me about this, but I'm not good at taking advice. Anyway, we I don't want to revisit that whole story. We had our reasons. Even if they were wrong, we had our reasons. No, that's a different talk. It's called Generics Considered Harmful. But anyway, another thing that, again, everybody sees in these things what they want to see. And so one of the things I wanted to see, I've always been a literate programming fan. So of course, this is a lost cause. Programmers hate to write. But now what these things are pretty good is summarizing programs. So, and the great argument or the protective rationalization that programmers use is there's no point in my documenting this because when I change the code, the documentation will be out of date, blah, blah, blah. Well, now the thing can go and automatically update your documentation. So you could even imagine environments where if you think of it, if you have a sort of a chat GPT-like thing where you're talking to it and telling it what the thing should do, you're going to get the program. You actually will get this sort of literate programming flow of explanation with a program embedded in it rather than the other way around. So maybe there's some hope for that. It's an idea. But there's also a lot of implications for applications, and eventually I hope to bring these two threads together. So RAG is an acronym for Resource Augmented Generation, for those of you who haven't been completely immersed in this wave of hype. And basically the idea, the problem with these LLMs is they hallucinate. They make things up. As academics, I imagine most of you have gone and asked these things about your work and found out how lovely, I asked it about Strongtalk. It gave me a decent summary that seemed a bit iffy. So I asked it for citations, and that was so much fun because it gave me these beautiful papers with very logical titles, with co-authors that I've worked with, you included, and plausible URIs for GitHub for things and everything. There was only one little detail. Not one of these papers existed. I wish they had. They all sounded really good. But it will make things up. So one of the things you can do here is to set things up so that you have it basically have it not answer, but have it ask it to answer you not the actual answer, but a query that would get the answer from something reliable, like a good old-fashioned database. Or if you can use vector databases and do embeddings. There's all kinds of techniques here that we won't talk about, A, because I don't have time, and B, because what do I know about this stuff anyway? But that it's a way of, you end up, when you build an application, you end up architecting this thing with tools like LangChain is the main popular one. Microsoft now has their own one called Semantic Kernel, I think. And there are going to be lots of these. There's going to be these frameworks that are all intended to basically create a pipeline, a sort of data flow of things where some of the things are queries to an AI, and some of them are queries to something else. And they take data, formulate new prompts for another AI, and kind of create the sequence. So eventually you can get an answer that you have a better chance of it being accurate. You use these techniques also to protect against jailbreaking. So you can basically, before, you can vet the query before it's gone directly to the AI and say, is this a query that'll cause my AI to go off the rails? You can vet the answer to see if it's suspect and things like that. So this is all stuff that's happening for applications. And then there's this can often involves multiple services, essentially actors, some of which are AIs. And there is this term mixture of experts, which works at both levels. It works both at more sophisticated models that are built of submodels, when multiple models or queries. And also, when you build this application, you will have quite possibly a number of AIs, possibly instances of the same LLM or of different LLMs that are being asked different parts of the question, or to prep the question into a form that will avoid problems. And the nice thing about all this is you pay the AI companies by the token. And so the more you ask, the more they'll pay. So if you actually want a reliable answer, you ask it about 10 things. Well, is this going to confuse you? Can you formulate a query? And you end up paying 10 times as much. So it's everyone's happy except the people who pay. But it's really interesting. And all of this really is reminiscent of data flow and actors and things that you people know more about than I do. So it's kind of interesting, but there are other implications for applications, and that's kind of where I'm eventually leading to. Another thing, of course, is I don't know if most of you have probably seen this picture at some point. This I believe is an actual old Word version where if you open all the options, you got something like this. It doesn't quite fit in the screen, but there. So the thing is, Microsoft has gotten a bit better. It isn't as bad as this right now, but nevertheless, one of the interesting things is that there's a lot less need for the sort of WIMP classic interface, because essentially we're back to command line interface, except the command line is actually natural language rather than this misshapen thing by a bunch of autistic Unix hackers, which is the horror of the command line. Like, is it dash dash or is it dash? So you can just ask, you can just talk to the thing, right? So this is great. And so you need less UI. You still need UI because some things, there are reasons to have a UI. There may be a real graphic, a visual metaphor for something that makes sense. Or if it's a repeated action, it's great to have a button or a form or something. But there's a lot less need for these complicated multi-stage things with nested menus and all this stuff. And what's more, you can customize it to the user. These things are pretty good at generating boilerplate UI code, and you can generate UIs dynamically on request. And so this will lead us to the point of essentially how we can actually make things better for people and customize things and allow them to customize things for themselves. One of the interesting aspects is I'm speculating here. This whole talk is just speculation, as you've probably noticed by now, is that OSs, right? When normal people talk about operating systems, they're not interested in fragmentation of disks and schedulers and things like that. They're talking about user interface, basically. Mac OS versus Windows. It's actually about the user interface. And this does matter. It used to matter more since Apple is gradually deteriorating, though they'll never quite reach the level. But anyway, the point being that all of this won't matter anymore. It's going to be commoditized because there's going to be some sort of AI agent that'll let people ask, like, you won't have to figure out, oh, how do I turn on the permissions for this, or how do I get to whatever. So a lot of these usability problems, I think, will go away because of this. And again, my thread here is how this connects to programming languages and how user customization may connect to programming languages. So yeah, we said that. And so another area where we can speculate is language implementation and eventually language design, right? So can we actually make this technology do something useful for us, right? So can we have, basically, are there implementations that were too complex or too hard to deterministically figure out? You know, when a user asks you for a feature in a programming language, the typical thing is, yeah, they have a scenario in mind where this would be great, but you have to come up with a set of general rules. Well, this will hang together, and that's much harder, right? But maybe if you have this wonderful technology, maybe now we can find implementations that are clever enough and can do reasonable things in circumstances that before we could reject. Better error messages are also, you know, can it explain to the user what the hell is going on? And so that gives you a bit more leeway. But the one that I'm interested in and I'm driving at is for local first computing. So how many people are familiar with this idea of local first computing? Okay, that's less than I thought, but that's fine. Local first is a name that was introduced, I guess, in a paper in 2017 for an idea that I actually tried unsuccessfully to push since 2004 or 5 or so, which is basically trying to get the advantages of both cloud computing and personal computing together, right? So cloud computing has many advantages. Essentially, it's a nice name for time sharing that exists since the 60s, but it does let you collaborate. It does let you have reliable backup on some server that someone else has to maintain. And it does let you access your stuff from anywhere, kind of, you know, from a kiosk in whatever. So it has some advantages, but it has disadvantages, right? It doesn't work if a network is non-existent, slow, expensive, flaky, whatever. For example, it means that you're, you know, if there's a service, someone turns it off and you're up the creek. Anyone remember Google Plus? You know, they promised they'd give it back to you. They gave it back to me. Someday when I retire, I'll have time to go through this jumble of broken links that they gave me and try and resurrect that data. But it didn't really work because no one actually bothered to test it. It's pretty clear. So relying on services is a problem, right? There's latency issues sometimes and so forth. So sometimes you want this advantage. And I hit upon this when I got my first Gmail account in April 2004. They announced it on April Fool's Day, somewhat symbolically. And then I got an account shortly thereafter. And for half an hour, I was very enthusiastic. I said, finally, Google will solve this problem and I'll be able to find things on my email. And no, they didn't. But I realized I also wanted this combination of what a local application could do. Anyway, at some point, some people, in the meantime, a lot of things happened. CRDTs in particular happened, which is a good technology to help make this work. Because once you do this, you have this problem that now, if it's going to work offline, essentially, and yet have this collaboration. So the setup is you have this distributed computing problem, and you basically have replicas of your data that have to be synchronized. Because now you can go off and connect to this from another machine, and yet your machine should be able to do it without connecting to a centralized server, right? So there's this whole problem of syncing the data. That's the thing. And this is a hard problem. And CRDTs kind of solve that for certain cases and whatever. But my dream was to do a language that would do it for you, orthogonal synchronization. It would be like orthogonal persistence for those of you who remember that stuff, right? But this is actually a hard problem because, what are the general rules for arbitrary data and so forth? And I've had ideas about that, but I've never gotten very far. But maybe this thing can do better, right? This thing can actually look at your specific code and come up maybe write customized synchronization code or things. Or it can just, if you have what the problem is, what happens with merge conflicts, right? Can it do merge conflicts for you? So that's one of my pet things, and I hope that we may be able to use that. Language design. Well, there's an interplay, right? So I hate Hindley Miller, okay? But there are, I think that I'm always found it's alpha to gamma, or the other way around, and I can never quite. The essential problem there is it's a global constraint solver, and therefore when it finds an inconsistency, it tells you there's an inconsistency, but it cannot tell you really where the error is from your perspective. But maybe we can have something that explains these things actually, and then maybe it's not a problem, and then I don't object to it so much. The same could be said for dependent types, right? Things that are perhaps a little too involved for the average human. Maybe things can work better, and so things that were only for real aficionados might be more plausible. Program verification is a really interesting one. This is, again, something that has had promise for as long as I've been in computing, which is a while. But maybe finally now, you can get these things to actually put in the right assertions and actually verify things. And maybe if they write them in a clear enough way, people can read them and actually understand, this is what it should do. And since it's past the verifier, that's good. And then the synchronization issue, which I just talked about. So there's all these interesting things that you might be able to do. But there is a problem here. This is David and Goliath. And so languages that don't have millions of lines on the internet, say you're doing a research language, say you're doing a DSL for some specific purpose, right? OpenAI has not read your million lines of code, and so it doesn't. Whereas, Python, it does a pretty credible job with your language. It will have problems, right? This was especially bad until recently with machine learning, because machine learning really needs masses of data. And what are you going to do if you only have so many thousands of lines of code in your language to begin with, right? This is getting better with the LLMs, right? Essentially fine tuning. You don't need nearly as much data, but you do have to somehow address this issue, because right now this has stacked it in favor of the incumbents, of the mainstream, whatever is out there that it's read, and the more of it, the better, right? So it's been a winner take all situation. So interesting. Yeah. This should fill up, but it isn't, but that's okay. I guess the network's slow, but this is not too important. But basically, I'm going to tell you a little bit about an experiment I did in last February to see what you can do about all this. And that was basically, I taught ChatGPT Newspeak. And it was an interesting experiment, as you'll see. Basically, I taught it like in context in chat, like you'd explain it to a person. And it finally got there. Yeah. So what happened there is it was good at some things, very good at some things, and very bad at other things. And so it's kind of interesting to look at the lessons from that. So here's some queries. This is sort of interposed from a long kind of chat where I started with telling you it's a language. It looks a bit like Smalltalk. That was very helpful because at least it knew some Smalltalk syntax. It was also unhelpful because the minute the Newspeak syntax and the Smalltalk syntax contradicted, it was really hard to convince it that to use the Newspeak syntax. It kept going back to its old habits, right? Just like a person, you can't train them. Here, Newspeak has this way of representing what would be, say, the standard prelude in a normal language, the standard stuff, as simply an object with a certain interface, right? It's an interface that includes, say, a message like collections, which will give you a module that supports the collection API that will support calls that'll give you class list or class map or things like that. It'll do this for all the things in the platform, actors, reflection, what have you. And so this class right here is an example. Let's collapse it a little so we can see a bit better. So it's set up with a module that imports a bunch of stuff, and then it has a nested class called platform that is at an instance of which is the actual platform object that you can go and get platform services like FFI calls or collections or graphics or what have you, right? And pay attention to this little method here, keep sources, which in this case, it says it's true. And so I'd explained this concept of platform a bit in more detail to ChatGPT. And here it had to say, basically, this is a platform that supports, in the context of the conversation, yes, it supports reflection, but not GUI. That's true. And it explains, this is all accurate. It figured out that these are the classes that are used to instantiate, say, collections for primordial soup was the class to use collections and so forth. So everything it said, it pretty much understood it. And it understood that there's, a method called operating system that isn't implemented. This is all very plausible. And it says keep sources returns true, indicating that the platform keeps the sources of the code being executed. Now, there is no documentation anywhere on the internet or in the code that says that is what it does, but it's a very obvious guess. And so it's pretty damn good, right? Now, it gets more interesting because the next thing I asked it is, why do you think it needs to keep the sources? And it said, because reflection. Because you're implementing reflection and you're going to need the sources. Now, I don't know about you, but if I had an undergrad student and I asked them this, I would be pretty impressed if they actually figured this out. So it has these insights that are pretty damn good, right? That's nice. Then I asked it about class hierarchy inheritance and virtual classes. So I asked it if it knew about those things, and it told me things that are not actually accurate. It was a little confused. Very plausible confusions. Again, it said, well, class hierarchy inheritance, you have this thing called inheritance, and there are class hierarchies. So it just thought it meant inheritance. And virtual classes, it read too much C++ crap, and it thought it was abstract classes, right? So these are plausible answers. And so I said, nah, what we mean here is this explains what real virtual classes are and how you override them and so forth. And then it said this. Of course it does. Well, the point is that most of this is not really written down explicitly, right? So stochastic parrot, if someone tells you it's a stochastic parrot, maybe it is, but so are you. I mean, it's pretty damn good. It's not clear that there's a difference. What real understanding is pretty much seems to work this way. So it basically, first of all, it came up with this. Can't select here. A beautiful sentence. This makes Newspeak a very flexible and powerful language. Now that shows that it's intelligent. Now, beyond that, it basically came up with a real example. We had talked about shapes and points and things, and it said, yeah, you could create a shape class and they could swap in polar points for Cartesian points while maintaining the interface. This is true, but this is not a trivial insight about how this all works. it's very impressive for a thing that, and again, it's not going to find this written down somewhere. It's not just regurgitating the obvious like pieces of text. So you can do a lot with in-context learning. What it could not do is get the syntax right? So in the end, you need to do fine-tuning, right? We've also done an experiment with the DSL internally where we said, okay, let's have it do abstract syntax so it won't get so hung up about this. That works a bit better, right? Essentially, we gave it a schema in GraphQL for the abstract syntax, and it spits that out, and then then we have a deterministic thing that takes the abstract syntax and gives us real syntax, and that's an easy problem, right? So that does help, but in the end, you want it to remember. Also, you don't want to pay it by the token to remember all these explanations every time. So in the end, you do want to fine tune, and so fine tuning is just something that everybody can do. But if you can do this in context, you can probably do it with fine tuning, and you can get it to really program and understand at some point. So that's impressive. And so this leads us to the future of like, why are we programming at all in the conventional sense, right? This is good. If you've seen like Demore's, his carefully selected GitHub demos, that's also pretty amazing what you can do in the right circumstance, right? And these things will get better. So ultimately, and I've said this before, I expect we're going to get to a point where you have this kind of Socratic dialogue with a machine. You just speak to it in natural language and say, like you would with a consultant. You tell it the problem you want solved, and it'll tell you, this is ambiguous. Did you mean this? Have you thought about that, etc.? Because really, when we don't know, as has been observed many times, programming is a good way for you to think through a problem. And essentially, we won't do that by writing code anymore. We'll have the damn thing think for us. And with what will happen to people is an interesting question. But that's where I think we're going. It's only a question of the timeline, which is hard to tell, but I lean towards sooner than you think. So we have this world where everybody can program, but not like we're used to, right? They don't program by writing funny sentences in context-free grammars, except that we might, it's like painting. Right? We have photography, but people still paint. We have cars, but people still ride horses. But people do Sudoku, right? It's going to be a kind of this side activity, right? Snobbish prep schools might ask, "Do you program? Like, do you ride?" Right? Sort of. And so, but it's not going to be this mass activity where it's go get a job and everybody's doing it, and it's a key to industry. So but there is one of the interesting things about this is there's also been another dream apart from there's been the dream of like the low code, no code, like democratizing programming. Everybody can program. Yes. And I always thought that the solution to that was sort of involve neurosurgery on a mass scale. But apparently now we can get it to where we can let people to control the digital environment around them. Because one of the problems was, okay, to really control it, you need to write programs, and people can't write programs no matter how much you tell everyone should learn to code and whatever. No, everyone will not learn to code, but it doesn't look like anyone will need to code in the foreseeable future. And so you want this kind of AI personal assistant. And this is actually something, again, I have my axes to grind as usual. When you talk about IDEs, right, and you think about the standard stuff, and I won't mention any names because I don't want to badmouth anybody. It's not like me to badmouth anybody. Ever, don't snicker. So the problem with say Eclipse, or well, Eclipse has been Eclipse, but it's the same with whatever all the others. They're just better versions of the same broken idea. The problem is, if you want to change its behavior, there are 50 features and 50 nested menus that it lets you do. And there may be plugins or extensions and whatever. And it's open source. And so you can go and read the million lines of source that it takes to make this thing work and figure out what you change. And then you can rebuild it if you can figure out how to build it in the first place. It's right. And I always give these Newspeak demos where I can show you, because it's a live system. You just go and you can click on a part of the GUI that you want to change, and it'll show you which code it is, and you can change it on the spot and see, right? So this is true, and this applied because this is something programmers use, and you can expect them to do that. What about the whole damn user interface that an ordinary user faces, right? That they'd like to be different. There's nothing for them to do, right? But suppose it worked that way. Suppose it was a live system and they didn't have to program. They just have to tell the AI what they want done, and the AI will do the programming, right? So you still need, but for this to really work, it still needs to be a live system. It needs to change on the spot. Your data has to be preserved. Your state has to be preserved. And so this is something that, as I said, everybody sees what they want to see in this thing. That's what I want to see in this thing. Now, this ties to the local first thing, because the local first thing is very much about user agency as well, right? It's about, just had an example with a colleague at work where he had been using, I think, some workflow app, I think Trello or something. And I think the story was that Trello was acquired by Atlassian, and then at some point the contract with Atlassian lapsed, and then this turned off Trello because nobody had figured out that this connected the two and so forth, right? And they had 14 days in which to try and resurrect this and work through customer support, whatever, before the data was literally destroyed, right? So this is part of the problem that Local First is trying to solve. It's your bloody data, right? It's not like the Google Plus thing that was, yes, Google's data guaranteed, blah, 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 right? They gave you this pile of bits back, which you have to do surgery on, right? So it's about user agency, people controlling their own data, their own digital stuff, right? And the ultimate control is to control the program, not just the data, right? That's another bit. One of my hobby horses has been that it's not just about syncing data, but about syncing programs. And so it's the question of how we do that. If it were anyone else, but that's somebody had to call him and congratulate him. So anyway, that's kind of the idea that I can see uses for this to make people program, quote unquote, but not in the sense that we do or we care about, or the tools we use are only in the background. But what we do need to do is, again, they need to be live systems. They have to be able to change on the fly, like some programming languages do. And but ultimately, we're going to get to a point where we're even designing these languages for the AI, right? Because since the humans don't do it, what features make it easier for the AI to actually produce reliable code? That's something to think about. And my goal is, live programming systems to help AI help people in the end. Of course, this only works if we don't get turned into paper clips. So I don't know how many people are familiar with the AI doomer kind of culture. If you didn't know what a shoggoth is, you probably are not familiar with it too much. But right, one of the classic examples is you have an AI and you tell it, I have a paperclip factory and I want make my paperclip factory as efficient as possible. Produce the most paperclips as you can. Well, it goes, it's one of those things like the monkey's paw story, right? Be careful what you wish for. Well, the most paperclips can be done by turning every available piece of material into paperclips, including humans and such, right? So the AI goes and implements that. So the idea that it'll get out of control and do us away, right? And since I thought of paperclips, well, remember Clippy? Here he is. So the interesting thing is now with all these AI assisted helps, we're actually getting a Clippy that works. And so maybe Clippy is the mask of the show. And so for a small fee, these slides can be made available to you. So my real point, of course, is not to leave you with the thought that Clippy is the mask of the show. That's one. You can take. There's two takeaways you can take. One was the previous slide, and one is this slide, right? And this slide is that the core vision, right? A thing for whatever the quote is for children of all ages, right? A tool or programming environment or whatever, for basically where people can control things and create things, and they don't need to be experts in something very exotic to do this. is that's a core vision, the vision of a machine where everything is under your control, like a Lisp machine or like the original Smalltalk machines, right? Before these things were exiled to tiny niches on unusable garbage. That's still what I care about, and I think there's an opportunity here. But we are at another inflection point, because the more likely scenario is we're all basically forced to pay a lot of money to the AI providers, right? Because there's also a tension in this AI between the open source models and the closed source models, and OpenAI is getting, of course, more closed all the time, because when your name is OpenAI, right? It's like Honest John Used Cars, right? Whenever someone puts something in their name, you know that it's going to turn out different. It's like there was this company who had this statement. What was it called? Don't be evil. So if someone says that, you know what's going to happen, right? So there is a real tension here, but we can make this technology so that it is easier to customize and put into people's hands. And that's all I had to say. And I don't know how much time I took. If there's basically, this was meant to provoke discussion, because obviously I don't know what I'm talking about here. So there you have it. Thank you.